Let's discuss a question from thermodynamics. We are asked to calculate change in entropy, so we will use the TdS equation. TdS is du plus pdv, and for ideal gas du is mcv dt, okay, and pdv, we'll just write pdv. Let's take ts on that, t on that side, because we want only the change in entropy, plus pdv by t. Okay, now remember that for ideal gas pv is mRT, that's the ideal gas equation. So p by t is mr by v, so let's use that as well in this equation. dt by t plus p by t is mr dv by v. Okay, this is ds. Okay, now if I integrate this on both sides, this throughout, okay, from the state s1 to s2, this is t1 to t2, and this is v1 to v2. So this I'll get change in entropy, which is what I want. This is mcp ln t2 by t1 plus this is mr ln v2 by v1. Now I know temperature change, the initial and final, so I can calculate this, but I don't know this. So how do I calculate this? I use the ideal gas equation at the state 1. So p1 v1 is mr t1. At the second point also it is p2 v2, using the ideal gas at the second t2. I want v2 by v1, so from this equation v2 by v1 is t2 by t1 into p1 by p2, and substituting the temperatures, the final temperatures, remember the initial state is given as p1 t1 and final state is given as p2 t2. The final temperature is 300, initial temperature is 300, the initial pressure is 100, is 200, so this is 5 by 6. Okay, so now all this data we can use it now. So change in entropy is, mass is already given, Cp is 5R by 2 Cv, so let's substitute that. Ln, it's T2 by T1, so ln 500 by 300 Kelvin plus mR ln V2 by 1 is 5 by 6. Now substituting for R value, remember what we need is per mass, because kilojoules per kg, so per kg is needed. So m, we need not substitute 10 kg, so m is directly to the left side, so m 5, R is 287, remember in joules, by ln 5 by 3 plus R is 287 ln 5 by 6. So if I calculate this, I'll get 314.19. okay, this is joules per kg Kelvin. Now in kilojoules it will be 0.314 kilojoules per kg. Now what is asked is specific entropy per kg, so 0.314, the answer is D. So always the change in entropy, use TdS equation. Thank you. Answer is D. Thank you.